Exercise 5.1, question number 3. Question number 1 and 2 given in the first video. This is the second video on chapter 5 and we are solving here question number 3. Draw a triangle ABC with AB equal to 6 centimeter. So AB equal to 6 centimeter, you will draw with scale. See, AB equal to 6 centimeter. From A to B, we are drawing 6 centimeter. This point mark A, this point mark B. Then BC should be 7 centimeter. From B to C 7 and C to A also 7. See, BC is 7, CA also 7. So that 7 you can draw only with compass, you see. You adjust the distance at 7. Distance between the pointer, needle and the pencil. It should be 7 centimeter, you see. So from B to C should be 7. So you draw an arc. You don't know where is the point. You draw an arc like this. Okay. And from C to A also should be 7. From A to C, A to C also should be 7. Same distance. It should be 7. You see, between the pencil and the needle, it is 7 centimeter. Pencil and the needle 7 centimeter. Okay. So you draw another arc from here, you see, and the point at which the two arcs cutting, that will be the point C. Now you can join CA, CB, CB and CA. Here you can mention AB is how much? It is 6 centimeter. BC is how much? 7 centimeter. AC is also 7 centimeter. Okay. Now we have to draw circumcenter of the triangle ABC. Circumcenter is drawn like this. We have discussed in the first video. We have to find perpendicular bisector of any two sides. I'll take one AB. Perpendicular bisector I am finding. So I'll put the needle at the point A and make this distance between the needle and the pencil little more than 50%. Little more than 50%. Okay. Little more than 50%. And we are finding the perpendicular bisector of AB. One arc this side, and without changing the distance from the point B, you have to draw again two arcs, you see. And where the 2 points intersecting, you will join these 2 points by dot line, not continuous line, dot line. Okay, you see. So we got the perpendicular bisector of AB, and we have to draw the perpendicular bisector of any other side. I'll find out for BC. So again, you have to adjust the distance little more than 50%. Okay, little more than 50% of the length BC. You are finding bisector of BC. So little more than 50% of BC we will make. And then you draw two arcs, one this side, another this side, from the point B, and again from the point C you have to intersect the two arcs, you see. And you will join this line with dot line. Okay, join these 2 points of intersection by dot line. And where the two, this is bisector of AB, this is perpendicular bisector of BC, and where the two bisectors meeting, that will give the center of the circle which you are going to draw. The circle means the circumscribing the triangle. So now you put the needle at the point of intersection. This is going to be the center, and you adjust the pencil at any one of the corner of the triangle. Say at A, then it must pass through B also. It is passing, you see. It must pass through C also accurately. It must be accurately passing. Okay. Otherwise, drawing may be little mistake. So it is passing nearly, yes, correctly. And then this is the circumcircle of the triangle, you see. This is the circumcircle of the triangle ABC. This should little extend actually. So we got the circumcircle of the triangle ABC, and asking you to make this center at O, mark it point O, and you are asked to measure distance OA OB, OC. Of course, OA, OB will be same. So if I join this OA, what will be the distance? Let me see. OA, OB. If you join now OA, OB and OC, you can measure by scale. Okay. So you see from O to A, how much? Marking exactly 0 with the point O, and then how much it is, you see 1 centimeter, 2, 3, 4 centimeter. It is exactly coming 4 centimeter. Okay, coming 4, yes, exactly coming 4 centimeter. Yes. So OA is same as OB, is same as OC, and it is coming 4 centimeter. Okay, OA distance na. Distance OA equal to OB equal to OC, because they are the radius of the same circle, and coming 4 centimeter. You can measure and see again, no problem. So this is the solution for question number 3 of exercise 5.1. Hey? And then question number 4, exercise 5.1. What is the least possible radius of a circle passing through 2 points A and B? So you just draw a line segment joining any 2 points of any length. They are not mentioning the length A and B. Then what should be the, see, through this point, if we have like this, say 2 points A and B, A, B. Now through this point you can draw many circles. You see, this is one circle, this is another circle, through this point another circle. So which circle will have smallest radius? Smallest radius will be the one which is having the diameter AB. The smallest radius will be the, what is the least possible radius of circle passing through 2 points A and B? So least possible radius will be the radius of the circle which is having the center at the middle point of AB. Least possible radius, middle, just roughly middle point. And if you draw through A and B, the least possible radius will be the radius of the circle which is having center at the middle point of AB. You will write the answer like this. The least possible radius is the radius of the circle. Least possible radius is the radius of the circle with center at the middle point of A and B. At the middle point of A and B. Middle point of A and B, that means radius will be equal to AB divided by 2. Now you see, if you draw any other circle through A and B, like this I am drawing one circle through A and B, it is going to have a radius bigger than A and B, bigger than this, bigger than the one passing through the point A and B and center at the middle point, say O. So least possible radius is the radius of the circle which is passing through point A and B and having center at the middle point. That is, the radius will be AB by 2, and this is the answer for this question.